November 2018, paper 6, variant 2. Magnesium ribbon was burned in air. Okay, it's always useful to write the reaction. Magnesium burning in air will produce magnesium oxide. Okay, this is tongues. If he asks for the apparatus, this is tongues. Suggest the appearance of the product form when magnesium ribbon is burned in air. Because this is a group 2 element, it will be white. Okay, you can say white solid, white powder, or you can just say white. Group 1, 2, and 3 and zinc form white compounds and colorless solutions. Name the product formed, magnesium oxide. The product from burning magnesium oxide in air was added to water and heated. The solution formed was tested with universal indicator. Suggest why the product was heated after it has been added to water. When you add anything to water, the reason probably is because you want to dissolve it. Why do we heat a solid in water? To increase its solubility, to make it dissolve better, or to make it dissolve and make a solution. Okay, so he added the solid to water and then he heated. Why would he heat? It's not a reaction. Take care, he's just measuring the pH. But the reason is to dissolve it or to make it a solution. E, suggest the pH value shown when a universal indicator is added to the mixture. Any value above 7 is accepted. Magnesium hydroxide or magnesium oxide are metal oxides, and metal oxides are basic. State 1 safety precaution. Actually, the only safety precaution that was accepted in the mark team was goggles. Okay, the only one that we took was goggles. Wear eye goggles because you're heating. Okay, no harmful gases are produced, so fume cover and well-ventilated lab are not accepted. Okay, question 2, his reacting solution L and M of hydrochloric acids. They react with each other and form iodine, and then he's adding iodine to sodium thiosulfate and using starch. Please all remember, starch, whenever it's used as an indicator. Okay, he used a measuring cylinder and it's inaccurate just in case he asks for an improvement. And then in every, notice what he's changing in every experiment. In every experiment, he's changing the concentration of solution L. He's adding here 6 and 4, then 5 and 5, then 3 and 7. When you change the volume of distilled water, this means you're changing the concentration. Here are the read time is 29, 39, 55, 111 seconds. Okay, these are the readings for the first experiment, for the 5 experiments. And this is the graph. Okay, from your graph, deduce the time taken for the mixture to turn blue-black if experiment 2 was repeated using 4 centimeter cube of solution L and 6 of distilled water. Of course, he gives you 2 numbers to disturb you, but 6 of distilled water and 4 of L. Since on the x-axis we have L, discard this number and use the 4. It will be 80 seconds. Okay. Which experiment was the rate of the reaction greatest? 1. Why? Because it had the highest concentration, so more particles per unit volume, and you can also say more frequent collisions. But the 2 marks, since this question was for 2 marks, the 2 marks on saying that it had the highest concentration or a high concentration and more particles per unit volume. Suggest an advantage of using a graduated pipette instead of a measuring cylinder, more accurate, of course. Suggest and explain a disadvantage of a pipette. Take care, the advantage of the pipette is always it's too slow. Pipette and burette are too slow. This is the main disadvantage of using them. Okay, or they take a longer time to add the solution. Suggest one way to improve the reliability, repeat and compare the results. Please always say, when he says reliability, repeat and compare. Cations and anions, solution, solid N and O were analyzed. N was ammonium, write the cation, sulfate, write the anion, and he's done tests on them. Describe the appearance of solid M. Okay, if he got anything, okay, I'll tell you a very good way to know the colors. If he got anything from the table of cations, okay, if he got anything from the table of cations, you choose the color in the table. So, مثلا, iron 2 gives green PPT, then the solids of iron 2 are green. Iron 3 reddish brown, then the solids of iron 3 are reddish brown. If he got anything that you don't know its color from the table of cations and is not a transition metal, choose white. Okay, If it's not from the table of cations and not a transition metal, then the color is white. Whatever it was, by group 1, group 2, group 3, ammonium, okay, there is no specific color for ammonium, so it forms white solids. Solid N was dissolved in distilled water to form solution N. Solution N was divided into 2 test tubes. Dilute nitric acid and aqueous barium nitrate, which is the test for sulfate, and I do have sulfate, so it's white precipitate. C, aqueous sodium hydroxide was added to N. The mixture was heated and gas produced. Ammonium, when it's heated with sodium hydroxide, remember ammonium with an alkali produces ammonia. So the litmus paper turns blue, and the gas produced is ammonia. Another, the other page, okay, a solid O was white, okay, and then he made a test by adding sodium hydroxide, no reaction. Test 2, silver nitrate white PPT. This is the test for chloride. Silver nitrate tests for halide. Chloride gives white, bromide gives creamy PPT, and the iodide gives yellow. Flame test, lilac color. So we have potassium and we have chloride, so the salt is potassium chloride. Now this question E was one of the very sneaky questions in the past papers. Is asking what conclusions can you draw about the identity of solid O from test 1. Test 1 said that it's white, it's a white solid. I know we've said before that group 1, 2, and 3, and zinc form white solids. So you could have thought in all of these, but take care. In the table of cations, you have calcium, okay? In the table of cations, you have calcium, which is from group 2. You have zinc, which is one of the things that give white PPT. You have aluminium, which is from group 3, okay? The only group that is not represented in the table of cations is group 1. So if he said that the solid is white, I'll think in all of those. But if he said that it doesn't give anything with sodium hydroxide, then it's not in the table of cations. In the table of cations, we have group 2, and we have group 3, and we have zinc. So it definitely should be a cation from group 1, which is true because it came out to be mean. معلش يا ولاد، هو ايه بقى اللي ما شفتهوش؟ معلش، قطع الزوم، قطع. هتجنن انا من الموضوع ده. اكتبوا لي اخر حاجه، اخر حاجه. انا هعمل لكم last question كله. اوه طيب، okay, I'll do it again. So the last experiment, 1 second. Okay. In the last experiment, he's saying when solid C and D separately react with dilute hydrochloric acid, one reaction is exothermic and one reaction is endothermic. Plan an investigation to determine which reaction is exo and which is endo, and which energy change is greater. Okay, which is exo and which is endo, we will see. If the temperature increased, it's exo. If the temperature decreased, is endo. Which energy change is greater? This means that we will see by how many degrees Celsius did the temperature increase or decrease. Okay, so if it increased by 10 and decreased by 15, this means that the endothermic had a larger temperature change or energy change. First step, you will add 25 centimeter of the acid to a conical flask, and then you will record the initial temperature. You must record initial and final temperatures in order to get the energy changes, okay? And then you will add 5 grams of solid C and record the final temperature and calculate the temperature change. You can say record the final or calculate the temperature, the energy change directly, okay? Finally, repeat the experiment with solid D using the same mass, of course. If you didn't say the same mass, you will not lose a mark, but you must say repeat the experiment with solid D and calculate the temperature rise. If the temperature rose, it's exo. If the temperature dropped, is endo. And you calculate, sorry, the temperature change. If the temperature rose, it's exo. If the temperature dropped, is endo. You covered the first bullet point this way. The second bullet point, which energy change is greater, the bigger temperature change means greater energy change. Yani if it increased by 10 and decreased by 15, I don't care. This means the endo gave me a larger energy change. He's not focusing which increased and which decreased. He's focusing on the values. Okay. So this is a simple diagram. You will add the acid, 25 centimeter cube of the acid, and you will add the solid, and you will measure the temperature change. Okay. This was November 2018, paper 6, variant 2 by Mr. Marco Milhat.